Hello everyone, welcome to Sources classes. So in this video we'll take a look at questions from the ISI Mstat PSA 2020 paper. So we'll start off with question number 1 and we'll try and see how we can go about solving this sort of questions. Okay, so let's just first go through the question. How many distinct straight lines can be formed given form that are given by the equation ax plus by equal to 0, where a and b are numbers from the set 1, 2, 3, 4, 5, 6 and 7. Options are given, multiple options are given, so E63, B57, C37 and D49. So let's take a look. Let's just first write the equation down. So the equation given here is ax plus by is equal to 0. Okay, so this is what we have in the equation. Now let's take a look. So if a is equal to 0, then no matter what value b takes, okay, except for b equal to 0, because we already considered a equal to 0. So b's value could be anything from 1 to 7. Okay, if we take that value, we'll have y is equal to 0. Okay, so this is what we have. And now similarly, if we take b equal to 0 in this case, okay, so the equation in this regards, again, for any value of a, okay, so for any value of a where a is the element of 1 to 7, the value of x in this regards will be equal to 0. Okay, so these are the two defining things we have. Okay, one, in case if a is equal to 0, then y will be equal to 0, and if in case b is equal to 0, then x will be equal to 0. Now we know a and b, they they basically can take values from 1 to 7, we know, because if we take a equal to 0, b equal to 0, we basically get the equation to be x and y equal to 0. Okay, so we know the values would lie somewhere in the range from 1 to 7 and from in the given set. Okay, so but if we take a look, a equal to 1 comma b equal to 1, a equal to a equal to 2 comma b equal to 2, a equal to 3 comma b equal to 3, a equal to 4 comma b equal to 4. Similarly, a equal to 5 comma b equal to 5, a equal to 6 comma b equal to 6, and a equal to 7 comma b equal to 7, equal to 7. So all these values will yield some equation in the form, will yield basically the same equation. Okay, so when they are equal, that is x plus y equal to 0, they all will yield this particular equation. Why? Because we'll take the common one and just substitute it with the 0, just send it to a 0 side. So x plus y would essentially be equal to 0. Now similarly, if we take a look, okay, so similarly if we take a look at the following pairs, the first group of pairs will be a equal to 1 and b equal to 2, a equal to 2 comma b equal to 4, and a equal to 3 comma b equal to 6. So all of this will basically yield the same equation, so you can just put it there. So in this case, suppose I put a equal to 1 here, so it will be x plus 2y equal to 0. Now if I put a equal to, so 2x plus 4y, which will 4y equal to 0, it will be in this regards. Okay, if you put this value, so essentially this will again be x plus 2y equal to 0. And similarly in the case of a equal to 3 and b equal to 6, they will all essentially give the same values. So we need to find such numbers which lie in this particular range. Okay, so similarly a equal to similarly if we another take a look, a equal to 1 and b equal to 3 will give the same value. Similarly a equal to 2 and b equal to 6 will give the same value. Here the multiplying, in the first number one, the multiplying factor between A and B is 2. In the second one, the multiplying factor between A and B is 3. If we again take a look number 3, so suppose if I take A equal to 2, B equal to 1 and A equal to 4, B equal to 2. Here the multiplying factor I am taking as half, so they will again essentially give us the same equation. Similarly, A equal to 6, B equal to 3. Okay. Similarly, number 4, if I consider what we can have, we can go with 1 by 3 multiplying factor, A equal to 3, B equal to 1, and A equal to 6, B equal to 1, B equal to 2. Okay, this again will yield us the same thing. Okay, so number 5, if we go, we can have, we can go with A equal to 2 and B equal to 3. So 2x plus 3y, which would again be similar to 2x plus 3y if I take 2 common. So A equal to 4 and B equal to 6. Okay, same equation, they'll add, just substitute all these values in this particular equation, you will essentially find the same equation. And lastly, if we consider number 6, that is A equal to 3, B equal to 2, and B equal to 2, and similarly A equal to 6 and B equal to 4. So these are the 6 possibilities that we have over here. Okay, now what we have all these possibilities that basically yield in the same equation. Now therefore, if we take a look, the pair of A and B that gives unique straight line equations are, so suppose, let me just point a graph. Okay, let me do one thing. Let me draw a small table here. Okay, this small table here. We take a few points, so this be A, this be B, and this be distinct points. Distinct points. Okay, that's what we have. So suppose A is 0, B can be any value from 1 to 7. So we have, okay, any value. So here we have one distinct point as we have seen here, and similarly in this case again, if we take a look, A is any value from 1 to 7, B is 0, again we have another 1. Okay, now if I take A equal to 1, okay, so B can be any value from 1 to 7. So for any value we have 7 distinct points. A equal to 2, if I take, B can be value from 2, so yeah, B can be 1, 3, 5 and 7, so 4. A can be 3. Okay, so if I take 3, so it can be 1, 2, 4, 5 and 7. In this regard, so it will be another 5. Okay, so just these are all the value points that we have got. Okay, just substituting value of 8 that way. Okay, and we have excluding the similar equation in this regards. So similarly for A equal to 4, we'll have 1, 3, 5 and 7, so another 4 in this regards. If I take A equal to 5, then I'll have 1, 2, 3, 4, 6, 7. So in this regards we have 6. Similarly, if I continue the same here, A, B distinct. Okay, if I take A equal to 6, then we have 1, 5 and 7, so 3. And if we have A equal to 7, so 1, 2, 6, all the points. Okay, so this will be 6. So now if we add all these things up, 2 plus 7, 9 plus 4, 13, 18, 22, 28, 34 and 37. So our answer will be nothing but 37 distinct points. What we have done, we have simply, for A equal to 1, we see all the common points we have removed. Okay, So all the common points we have removed in this regard. So and that way we have simply gotten our answer. So 37 will be the correct answer. So I hope this thing is clear. We'll continue our discussion on the similar sort of questions in the subsequent videos. So until then, I'll be signing out. So thank you so much.